Hello everybody, welcome to the first lecture for Math 099 Developmental Math. So like I said in my introduction video, this class does not assume any prior knowledge of mathematics whatsoever. With that being said, I'm sure most of you do have some experience with math, so if you want to work more quickly through these first few sections than I go, that's fine. You could always watch the videos at like 2 times speed or whatever. But the important thing is to really make sure that you do understand these first few sections, because these are really the core foundations of mathematics. Okay. So we're just going to follow the book pretty closely at first. Eventually we might jump around a little bit. But we're going to start right at section 1.1, which is, as it's laid out here, whole numbers. Okay. So, what do we mean by a whole number? Okay. So, this definition is not from the book. This is just, my own words here. A whole number is a number that represents and let's say a complete, put this in quotes because what I mean by this, I want to say like a whole quantity, but we shouldn't use the word to define the word, right? It's a number that represents a complete quantity. So what I mean by this is it does not represent like part of something, right? Like that's where a fraction would come into play. If we have a half of something, that's not one complete thing, right? It's half of a thing. So this would be the numbers like 0, 1, 2, 3, 4, etc. The common numbers that we're accustomed to. It does not include negative numbers, right? Because that's not really a complete quantity. It's like taking away a complete quantity. But we'll talk about that in chapter 3. So we'll try to avoid negative numbers until then. And we'll talk about fractions and decimals in chapters 4 and 5 respectively. So right now, we're just going to focus on whole numbers, okay? So these would be the numbers, like I said, 0, 1, 2, 3, ... Okay. Now, what do we know about these numbers? Well, we have, I wrote ... here, but let's keep going for a little bit here. Whoops. 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's say ... What do we notice here? It's something you probably know, but maybe you've never really thought about. Only these first 10 digits here, including 0, are using unique symbols. After that, on 10, 11, and 12, and etc., we're using combinations of symbols, right? So we only actually have 10 symbols for numbers, which is why we have what's called the decimal symbol system, right? Decimal system. Deci is a prefix meaning 10, and that comes from the fact that we have 10 digits, right? This is in contrast to other number systems like binary is another common one, right? Where you have the bi means 2, so you have 2 digits, 0 and 1. And there's been many other types of systems, like some number systems had 60 digits, for example. But we have 10. Okay, so once we run out of those 10, if we want to represent higher quantities, we start using combinations of them. Okay, and the combinations here we keep track of what numbers it's representing by using what we call place values. Okay. Oops. So let's look at the number 100, or let's just look at a small number first. Let's look at the number 15, right? So the number 15, we have 2 digits. We have a 1 and a 5. So how do we know what quantity this represents? Well, we use what's called the place values, right? So with place values, okay, so the 1 and the 5 is in what's called the ones place, right? The 1 is in what's called the tens place. Okay, and notice when we get to 10, that's when we start using the tens place. And likewise, when we get to 100, we'll start using the hundreds place, and so on. So what this really means is that what we have here, we have 1 10 and 5 ones. Okay. In other words, this is really just a fancy way of saying that 15 is 10 plus 5. Okay. If we like break up the place values like this is what we would see. There's if we really wanted to represent it with multiplication, which is kind of getting ahead of ourselves because we're not actually talking about multiplication yet. But for those of you who are comfortable with it, what this is saying is this is 1 times, let me use the X for times here, 1 times 10 plus 5 times 1. Okay, it's saying that we have 1 10 and 5 ones. Okay, so this is what we're really saying here. Now, if this doesn't make sense, that's okay. You don't have to worry too much about this. This is just really breaking it down. We really just want to worry about, okay, what are these place values called and how do we remember what they're called? Okay, let's look at another example. Let's say we have 123. Okay, well, the rightmost digit is always the ones place, assuming we don't have any decimals. Which right now we're not going to assume we have any decimals because we're not going to talk about decimals until chapter 5. Okay, so this is always the ones place. The second number is always the tens place. Now the third number we haven't seen before, this is the hundreds place. So like I said, once we get to 100, we start using the hundreds place because we have 10 digits, right? When we have 2 places for them, there's only so many combinations we can make. Once we run out of all the possible combinations, we have to add on a third place so that we can make more combinations. And then we use up all of those combinations, and then once we get to 1,000, we run out. So now we need to add another place, which would be the thousands place. And then so on, we go to the 10,000s place, the 100,000s place, the millions place, so on and so forth. Okay. So we always start from right to left with ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, etc. Okay. So 123, this is saying that we have a 1 in the hundreds place is like saying we have 100. Really, it's like saying we have 1 times 100. A 2 in the tens place means we have 2 times 10, so 2 tens. Plus a 3 in the ones place means we have 3 ones, right? So we have 3 times 1. So I'm using x as the multiplication symbol here, which we won't do later when we actually use x as a variable. But for right now, we'll just use x because it's usually the first symbol we use for multiplication. Which another way of thinking about this is that 123 is just 100 plus 20 plus 3, right? If we want to break it down that way instead without the multiplication. But it's saying that we have 3 1s, we have 2 10s, which makes 20, and 1 100. Okay. So if we have something like this, and we want to say identify the hundreds place, then we start at the right and start at the ones place, and then so with the 7 here, and then just go over and count all the places. So we have the ones place, the second one is the tens place, the third one is the hundreds place, right? So it would be 4. And then 0 is in the thousands place, and 1 is in the 10,000s place. So what we want to do, and I encourage you to look at the book in this section because it uses blocks to make this a little more accessible. It's hard for me to do that on here, but definitely take a look at the book on this section. So, one thing we commonly want to do with numbers is we want to round them, right? Because a lot of times, like with 10,457, we probably oftentimes don't really care about being that precise. Maybe we just want to know that it's close to 10,450. Or maybe we even just want to know, it's around 10,000, right? That's all that's important to us. So we do what's called rounding the numbers, okay? So how do we do that? And before we move on here, the book does talk about naming the numbers also. I'm just skipping that because I'm kind of doing that like as I go, right? I'm showing you, hoping that you can pick up on how I'm naming these numbers, like 10,457. Okay, so another example would be 25,687. So see, I say the 2 and the 5, the 25, put those together, and the comma says, okay, now we say 1,000. And then we say this part as 687. Okay. So the commas kind of separate the numbers into groups, right? If I have something like this, well, we have 10,256,879. Okay. So the commas again are breaking these numbers up into groups. So we've grouped the 10 part together, the 256 part together, and the 879 part together. And each new comma has a different place value. So this first comma is for the thousands. The second comma means, say, millions, right? And we read it left to right. So we go 10,256,879. Okay. But yeah, the book goes more into detail with that. I'm just kind of hoping you can maybe pick up on it as I'm saying the numbers verbally. Okay. So let's talk about rounding. Okay. We often want to round to a specific place value because sometimes, like with 10,457, sometimes we just care that it's close to 10,000. Sometimes we care that it's close to 10,450, right? It depends on the context. If we're talking about how much a car is, for example, if a car was $10,457, maybe say we only have like a couple $100, then we might think of the car as just being it's around $10,000 because we don't have anywhere close to that amount of money anyway, so why bother being more precise than that? We're so far away as it is. But if the car is $10,457 and we have, say, 10,000, now maybe we want to be a little bit more precise because we need to know exactly how much we need to get to the point where we can afford the car. So then we say, okay, it's $10,457 exactly. Now I actually care about all that. Maybe we still don't care about the cents afterwards, right? So when we talk about rounding, we mean what number is this number close to, okay? And exactly how close depends on the context. So let's say we want to round 10,457 to the nearest 10, okay? So we care about how much it is up to, this actually, that probably, I can't think of a context where we would care about it that precisely. Let's say to the nearest 1,000. Okay. So I said it was 10,000 already, but how do I know that? Okay. So we look at the 10,457. If we want to round it to the nearest 1,000, naturally we should first identify which place is the thousands, right? And if we start from here, this is ones, tens. Oops, sorry, let me do it on the screen. This is ones, tens, hundreds, thousands, right? So the 0 is the thousands place. If I want to round to the nearest 1,000, well, in order to know if I'm closer to the last 1,000 or to the next 1,000, so 10,000 or 11,000, I need to look at the next number after it, right? This 4 right here. If this number is between 0 and 4, that means I'm closer to the last 1,000, the 10,000. If the number is 5 through 9, it means I'm closer to the next 1,000, to 11,000, right? And you could check that by saying, looking at the whole 4,057, 457, I'm 457 away from 10,000, but I am, what is it? 543, I think. Yeah, I think 543 away from 11,000, right? So 543 from 11,000 here, and then 457 from the 10,000 here. But we don't need to know, like I said, precisely how far away we are from each. If we just look at that 4, it'll tell us enough information. This number, because it's either 0, 1, 2, 3, or 4, it means that we're going to be closer to the 10,000. We're going to round down, okay? So since the number, I'm going to write this symbol for number. Since the number in the hundreds place is 0, 1, 2, 3, or 4, we are closer to the last 1,000 so we do what's called rounding down, okay? If it were the opposite, if it were 5, 6, 7, 8, or 9, we would round up, okay? So let's look at an example of that. If we want to round the same number to the nearest 100, okay. So now we have the same process, but we're going to do it with the hundreds place. We're going to locate where is the hundreds place. right? And the 7 is in the tens, I mean the ones. So the 5 is in the tens, the 4 is in the hundreds. So this is the number we're looking at to round. So whether we round up or down depends on the number to the right of it, the number in the tens place, the 5, okay? Because this number, the number to the right of it, is either 5, 6, 7, 8, or 9, we round. So this was round down. Now we round up to 10,500. Okay. So when we're doing this, we're asking ourselves, is 10,457, is it closer to 10,500 or 10,400? And the 5 being in the tens place tells us we're closer to 10,500. And we could check that if we do the math here. We are 43 away from 10,500, whereas we are 57 away from 10,400. Okay. Okay. Let us move on. Like I said, I don't want to spend a ton of time on these first few sections because, usually most people, coming into this have seen it before. So this is just a matter of like remembering it. Even if it's been 10, 20, 30 years since you've seen it, hopefully this helps you remember it a little bit. Now, of course, because you're watching this video on your own, you don't have to move on yet. You can go through this again. In fact, I would encourage you to if you're not comfortable with it yet. Feel free to go through this again. And if you still want more information about it, contact me and I can talk to you one-on-one directly. Okay. We can go through some more examples. And of course, there'll be examples of this in your homework too. So let's move on to addition. Okay. So we'll start with adding single digit numbers. Okay. So 3 plus 4. Okay. So what does this even mean? Addition. Okay. Addition is the act of combining maybe you shouldn't say combining. Again, these are my own words, not from the book. So is the act of putting numbers together okay, to make a new number. That's a very rough definition. But all I'm trying to say here is we take 3 and we take the 4, we put them together, and then we come up with a new number from that. Okay. I mean, this definition could really apply to subtraction and multiplication as well, in a way, depending on how you interpret the putting numbers together part. But let's look at visually what this means, because I think that's the best way to see it. Okay. So if I have 3 blocks, right, and I have 4 blocks, okay, when I say I want to add these together, what I mean is I want to take these 2 sets of blocks here, put them together, and then count how many do I have total. Okay. So putting these together, literally just connecting them. Okay. So these 3 right here are these 3, and the rest, the other 4 are these 4. Now, how many do I have total? Okay, and we go 1, 2, 3, 4, 5, 6, 7. So this is just a visual way of saying 3 plus 4 equals 7. Okay. So I take one quantity, I have another quantity, we put them together and say, okay, what's the new quantity? How many do we have in total? So essentially what I'm saying here is, like, with single digit numbers, we're just counting. Okay. If I have um two blocks, and now I want to add it to 9 blocks. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 plus 9, how many is that? Well, I don't even really need to draw the other picture where I put them together. I can just go through and count, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So we're just counting the total. Now, this is a good way for single digit numbers, but once we start increasing the numbers, this becomes very inconvenient, right? Not impossible, just very tedious. If I do something like 12 plus 15, okay, now we could draw 12 blocks and 15 blocks and count the total, but it's going to take a long time. It's still reasonable, but what about now when I want to do 81 plus 105? Right? Again, it's possible, but it's going to take forever. There's got to be a quicker way to do it. And there is. It goes back to the place values. Okay. I know that the 12 has 110 and 2 ones, and the 15 has 110 and 5 ones. So what I can do is I can take the ones and put those together, take the 10s and put those together, and then see what our total is. So the way you would have seen this before is we write them on top of each other like this, and we use this bar down here as our new equal sign, and we put the addition on the left side of the bottom number there. And we line them up with their place values. So you can see we have the ones values lined up here, and then we have the tens values lined up here. And now we go right to left, adding up all the ones, adding up all the tens, and then if we have more numbers, doing the same thing. So 5 plus 2, well, we can just count them. If we have 5, and then we go 2 more, 6, 7. Okay. And then we put that underneath the ones, because if we have 2 ones in the first number, 5 ones in the second number, altogether we have 7 ones. Now we have 110 in the first number and 110 in the second number. So altogether we have 2 tens. So at the end of the day here, we have 27. Okay. So we can just break it up by place value and see what we have overall. Now this one, there was no issues, right? It was pretty clean cut. But what about what happens if it's not? For example, whoops. What if we have 23 plus 39? Okay, 23 plus 39. Well, we'll try to do the same thing. We have the place values lined up. So we'll do 3 plus 9. And when we do that, we'll do it on the side here. It's just one more than what we did earlier with the 2 plus 9, right? 3 plus 9 is just one more, so we get 12. But we can't really put 12 in the ones place because, it's 2 digits instead of 1 digit. So 12 ones means we have 1 10 and 2 ones, right? So we say 12 ones. Well, we don't normally have 2 digits with just ones. So we can put part of it in the tens place, right? So we have 110, and then we still have the 2 ones left over. Okay. So what we do is we take the 2 for the ones in the 12 and we put it with the other ones. But then that 110, we carry it over to the tens. Okay. So we do what's called carrying the 1 here. We take that 110 and we put it with the other tens. Okay. And then we look at, okay, how many tens do we have, including that extra 1 that we have from the ones. So 1 plus 2 is 3, and then plus 3 we have 6. Okay. So overall we get 62. So like I said, that's called carrying the 1. Okay. So we carry the 1. So this is pretty much the way it goes for all of these. In fact, if you can do this problem, no problem, then you can pretty much do any addition problem. It's just a matter of lining up the place values and doing this for all of the values. So let's try one with more digits now. Let's try 7,836 plus 10,587. Okay. We have to make sure we get the place values lined up here. It doesn't really matter which one goes on the top or bottom, so we usually just use the left one and put it on the top. One of the nice properties of addition is that the order does not matter. Right, 5 plus 7 and 7 plus 5 are the same thing. And that won't be true of subtraction. Okay, so it specifically is nice for addition. Now, one thing I didn't mention is the comma for the thousands. If we have like a number like 7,836, putting a comma between the thousand and the hundreds place is considered optional. But in this case, when we have another number with a comma, it can sometimes help you save your place. But I might not always write it. So here we have the ones place, the tens place, the hundreds place, the thousands place. So here the 7 is the ones place, so we got to line those up. Then we have the 8 in the tens place, the 5 in the hundreds place, the 0 in the thousands place, and then the 1 in the 10,000s place. The 7,000 number, it doesn't have a 10,000s place. So we're just going to leave that blank. But if you would prefer, we can kind of imagine that there's a 0 here. Because putting a 0 in the 10,000s place, that doesn't change what number this is. It just says that we have 0 10,000s, which we already knew, right? Because we don't go up that high. But I won't write it, but feel free to write it if you're more comfortable with that. So then we just go on and we do our addition like we did before. 7 plus 6 is 13. Right, so the 3 goes into the ones place, but that 1 comes over to the tens place. Okay. So we carried the 1. Now, how many tens do we have? 1 plus 3 is 4, plus 8 is 12, right? So we have 12 tens. Now, just like before, that 1, we have 2 digits here again. So if we have 12 tens, then, that would be like having, if we do 10 plus 10 plus 10 12 times, it's like 120. So that 1 is really part of the hundreds. Okay. So we would carry that 1 over just like we did in the last step. And that goes over in the hundreds. But that 2, which is part of the 20 and the 120 I was talking about, that stays in the tens place. Okay. And then, so we're just doing basically the same thing. We keep the rightmost number in whatever place we're in and carry the rest of the numbers. 8 plus 5 plus 1. 8 plus 1 is 9, plus 5 is 14. All right, so we have 14 hundreds. But again, the 4 is definitely part of the hundreds place, but that 1 carries on over into the thousands place, right? Because 14 hundreds would be 1,400. So we have 1 in the thousands, 4 in the hundreds. And then we can bring the comma over too, because now we're moving on to the thousands place. So then we have 1 plus 7 plus 0. If we add 0, it doesn't do anything. So we're really just looking at 1 plus 7 to get 8. And then here we have 1, and then we're not adding anything to it, so it just stays by itself, right? So we just have, at the end here, 18,423. Okay. And so we could add as many digits as we want, and this process would remain exactly the same, right? So once you know how to do it for 2 digits, you can just translate that into the higher digits. Okay, I think that is everything for addition. So I'm going to go ahead and stop there. Actually, let me do one example where we have more than 2 numbers, now that I'm thinking about it. What if we have, 3 numbers? Then how does it change? Let's say we have 124 plus 78 plus 1,567. Now notice I was careful to line up the place values here, and that's probably the most important thing we want to do. We just want to make sure the place values are lined up properly. So we have all the ones lined up, all the tens lines up, all the zeros lined up, all the thousands lined up. Okay. And that's pretty much all it comes down to. And then once we know we have the place values lined up, we do the same process we just did a second ago. So 4 plus 8 is 12, plus 7 is 19. Okay, so we have 19. Again, the 9 goes in the ones place, the 1 gets carried over to the tens place. Now 1 plus 2 is 3, plus 7 is 10, plus 6 is 16. So we have a 6 in the tens place, and the 1 gets carried over to the hundreds place. 1 plus 1 is 2. There's nothing in the middle part here, so we just ignore it. It would be like a 0. 1 plus 1 is 2, plus 5 is 7. Okay. And now 1, it doesn't have any other thousands to be added to, so it's just like adding 0 to it again. So we have 1,769. And we could add as many numbers as we want to this, and it would remain the same. Okay. So yeah, I think we'll stop there. So again, feel free to, I would encourage you, to go over this again a second time since you have the video here. Do some problems of this on your own. I will put up some problems for you guys to work on regarding this. And next time we'll look at subtraction, which is, basically the opposite of addition, and multiplication, which is also related to addition. And then after that we'll be in division, and that's all for the arithmetic section. Okay. So with arithmetic, really, I've been teaching you kind of like the theory here behind it and giving you a few problems to do, but the best way to get good at doing this arithmetic is really just practicing. Okay. A lot of this is just remembering the process of how to do the problems, and the best way to remember that process is by doing a lot of them. Okay. Just doing it over and over again. So, thank you guys for watching, and I will see you on the next one for subtraction.